Hello, hi, I'm Owen from Scan2Plan. I'm joined here today with my friends and colleagues who we've all just worked together on a really exciting project at the Cathedral of All Saints in Albany. So I'd like to introduce, let's go around and introduce ourselves, starting with Bryan.
Hi, so I'm Bryan Clapper from Clapper Structural Engineering. I'm the structural engineer in the project.
I'm Megumi. I work with Scan2Plan as the studio operations manager, and I work with Point Cloud registration.
John Zagame. I was asked to be the project manager and coordinator for the Guild House project for the cathedral by its dean, Leander Harding.
And I'm Fleet Howard. I work at RPI. I'm a lecturer there, and I led a design studio in the Guild House.
So, well, at Scan2Plan, you know, one of our true honors is to be able to save endangered buildings. And in this case, this is a really exquisite building that was on the verge of extinction. And so John approached me. So I'll let him introduce the project. Thank you, John.
Thank you, Owen. This project began a little over a year ago with a conversation with Professor Rhett Russo at RPI and Professor Hauer. And we were fortunate enough that RPI School of Architecture agreed to take this project on as a studio project. And it has made all the difference in the world because it gave the project credibility and a public face that it really needed. This building had been abandoned since the 1970s, and just reviving interest in it was a major hurdle. So what we did is we began to engage the people that we thought could help us, and we started with Scan2Plan because both Professor Hauer and Professor Russo indicated that having a scan of the building was one of the prerequisites. And we were told if RPI was to be able to be involved in this effectively, we should engage Scan2Plan. That led to a conversation with Owen, and he was good enough to take this project on. And that's where the involvement of Scan2Plan began. And I'll turn it over to Megumi Call, who was good enough to come into a rickety old building and take the time, a few days, to do a really decent scan of the building that has been very useful to the different players. We actually put this scan up on our website as well so that people can access it, and the Matterport that was done those 2 days. And we found it to be very effective in getting interest in the project. So Megumi, I'll turn it over to you.
Thank you, John. It was a pleasure to go through that building with our scanning supervisor, Alex, and following his instruction on how to do the scans and being able to assist with that. I'll talk a little bit more about our scanning process and Point Cloud registration. What we see right now is one burst or one singular scan point and all the points that are collected in that scan. These individual bursts then get registered together. And once combined, we end up with a point cloud such as this. I'll turn it onto our color coordinating modes that you can see how each of the scans then coordinate with one another and combined end up with a tolerance of 0 to 1/8 of an inch from a point to any other point in the point cloud. So each of these colors correspond with a scan, and the blend of these scans then creates the unified point cloud. When we bring this in to Revit, we see the point cloud over the model. This becomes our single source of truth, which then verifies and validates the project moving forward. As I turn off the point cloud here, you can then see the model that was made through that point cloud and through that verification. I'll turn it over to Owen to talk more about our process. Thanks, Owen.
Oh, thanks. I thought I would share, John mentioned that there was a 3D tour of the, but so this is sort of our, give you a sense of what this building looks like on the inside. So this is a photo 3D tour, and a lot of times, you know, the architect or the engineer will like to have something like this side by side with the model and the point cloud so they can really, you know, zoom in and actually see all the details and really look at everything very clearly. So this way you can kind of walk through the whole space and see it all. You zoom in on details and really, you know, see everything very clearly. This will pop out, and then you can, you know, navigate to other parts of the building. So, here's Megumi on site, doing some capture, looking like a superhero. And so then I thought I'd also show, this is the model. So like with that 3D tour, you can look at something like this and this kind of structure, and you can look at it right next to the photo documentation, and you can really kind of see the difference. And then as Megumi showed, you can also turn the point cloud on and off inside of Revit, so you can actually see everything with real validation. But I just thought I would show this model a little bit. So we have all these kind of structural elements. And because of the sort of degradation of the building, there's a lot of very like irregular structure, which I think we did a pretty good job of documenting in this model. Yeah, so I'm going to throw it now to Bryan, who will show us how he's actually applying these deliverables to his analysis.
So this is the walkthrough that Owen was just showing. And the first step for us was to do an evaluation of the structural elements throughout the building. And what we use this for is to get a sense of the different areas to take a closer look at when on site. So we studied this for an hour or two, and we really got a sense of where we need to look closer at the site visit. So you could see, you know, obviously the floor is very damaged here, so that was an obvious one. There's some issues with the wall here. You can see some degradation here. So we kind of like mapped all these areas out before we got to the site, which was helpful. So we kind of know what we're getting into when we get there, and we kind of prepared with a plan on what to look for the structural evaluation. So that's one way we use this service. The other thing that we did is that when we were actually doing the drawings, we were able to get all the geometry from the point cloud. This truss has very specific geometry. So when we go into Revit, we would go, you know, just cut a section, and now we have the exact geometry of that truss, versus trying to get that information and do the measurements by hand would, you know, be a little bit tricky, especially how high it is off the floor. So this, we were able to just pull those dimensions and put it right into our calculation software, which was really nice. The other thing that we do is we cut sections in specific areas as we're working through it. So that section will give you the data that you need. Say if we want to know which way the floor joists were running or what the sizes were, we can very easily just go into one of these levels, cut a section like anywhere along there. Let's do this quick. Sorry. I'll go to a different floor plan. Like here, we just cut a section and we were able to get to this and see the trusses. Like I said, also, if I cut a section the other way, we can see the floor joist sizes and spacings. So by doing that, we're able to get a lot of data from the model. We also see deflection too. So we can see how badly deflected this is. And that helped us find, you know, this is pretty obvious on this job, but on other jobs, it helps determine what's going on with the structure as far as the deflection, things like that. So that's just an overview of how we use the point cloud.
Fleet, how about you guys? What have you what did you work on this with your class?
Yeah, so we ran a design studio, working closely with John and I guess the Guildhouse team, Dean Harding, the contractor they have on board, and also Bryan was a huge help. And the point cloud was a really useful base for us. So I'm going to share just a few things. Oops, I raised my hand instead. Yeah, so we use the point cloud and the Revit model as a base for Megumi was talking about kind of the accuracy of it. It was really helpful for us to think about well, to understand the existing conditions of the building and also to use reference point for drawings. These are some images of one of our projects in which the proposal is kind of for a building within a building idea. There's this, the problem of the existing envelope and its thermal barrier and how that might be navigated with the need for a new thermal barrier and also some of the structural bracing that will be required. Bryan was extremely helpful to us. We had a couple calls with him in which he answered all of our questions, which was amazing. I'll flip through a couple of these, but basically the basis for all of these models and drawings came from that Revit model, and the point cloud and Matterport was a great reference. We visited the site, but it's always nice to have access to go back to that Matterport and kind of see inside, and because there are always things that you don't capture, in photography when you're on the site. So it really provided us an ability to feel pretty confident in the design schemes. It's Guildhouse is not a huge building, and John has some pretty ambitious programmatic ideas. One of the ideas being the school, another idea is being potentially a community center. So the design here was really tight. And having kind of a very accurate base to work off of was extremely helpful. There's also the challenge of the truss in the ceiling of the current ceiling of Guildhouse, and how that would be navigated if there is a separate envelope. So having an accurate depiction of that truss was really helpful for the students. These are just a couple of kind of final images from one of the projects. So that's kind of an overview of one project, but kind of being able to produce really accurate base drawings and integrate the design work was really helpful. I haven't run a ton of adaptive reuse studios, but I think this one was a success and was definitely an area that kind of I want to develop further with students, particularly within the kind of climate-driven research that I'm doing. But it's critical to have that base to understand what you're working with. So yeah, I'll stop sharing. Thanks.
Thank you, Fleet. Appreciate it.
Yeah.
I love this project because it's adaptive reuse and historic preservation and saving buildings. And these are all things that they're all the reasons that we really founded this business. So, and also just being able to work with amazing creative people like yourselves. John, why don't you tell us how things are going with the project and where it's going?
Thank you. Let me start by beginning with a description of how we structured the cathedral's approach to this project. We created a 501c3 foundation, the Pioneer Foundation, which has been raising the basic funds to do the engineering studies and architectural studies here at the beginning. And through that Pioneer Foundation, we were able to engage Scan2Plan and then Clapper Engineering, Bryan Clapper. And where we are now with the project is that based on the foundation that you all have helped to lay, we are beginning to get some success with raising funds to pay for both the architectural and engineering planning and with the actual construction itself. One of the issues with these construction grants that we've applied for from the state is that they're strictly limited to the construction portion of the project. So we have to raise the funds for the engineering and the architectural separately, and we're doing that. We've reached out to the Landmarks Conservancy in New York, which has a Sacred Sites program, which is helping to fund this. We've spoken recently with the Preservation League of New York, which has funds that are available to fund these kinds of projects. And we just got some good news recently from Senator Neil Breslin, our local state senator, a capital grant for $250,000 that we can use to match another grant that we've applied for to the Department of Parks and Recreation, which is specifically for historic preservation projects. Those two grants together would equal about $1 million. And that, as Bryan can tell you, will probably just scratch the surface here in terms of stabilizing the building and getting it in a position where it can be redesigned and reused. And the key to this will be Clapper engineering at the beginning, because we have to stabilize the building and bring this building to a point where it doesn't fall down and it can be rehabilitated in the future. So that's where we are right now. We're pretty comfortable with the prospects of getting funding for it, but I'll go back to the beginning. This started with a conversation with RPI. It was because Fleet Hauer and Rhett Russo were good enough to involve RPI in the project. That gave us a lift off the launching pad. And then the introduction to Scan2Plan, which brought a great team to work on the project. And then through Owen introduced us to Bryan, and Bryan came into the project. So we have a very good, tight RPI-oriented team here that I think can make this project go in the future. It's a multi-phase project. It's going to take several years. And every year we're going to have to raise more funds to keep it going. But we're grateful that all of you saw fit to engage in it, because we believe you all are the gold standard in terms of making projects like this go forward. And let me just say one other thing. This is really emblematic of what can happen with historic preservation. There are hundreds of buildings in upstate New York, especially old church buildings, that are crying out for reuse. And so I'm hopeful that this can be the beginning of a collaborative process for all of you to move on to other projects. For instance, here in the Diocese of Albany, there's many, many buildings that need to be reused, reimagined, if you will. And so I'm hopeful that 2 or 3 or 4 years from now, there'll be other projects for the companies and maybe RPI to take a look at, including some things that relate to this specific project. We're looking at some of the things that Professor Hauer and Josh Draper, another professor at RPI, worked up, which would allow us to do a geothermal and possibly a hybrid geothermal and solar heating and cooling project in addition to this building that NYSERDA, a state agency that is available to fund these projects, could give us funds for. So we're in a good position, and I thank you all for making it possible.
Thank you, John. And I remember at one point you told me it would have cost the cathedral $2 million or something like that just to demolish the building. And so when you think about the incredible structures we have, the incredible cultural legacy that we have from these buildings, and the ability to save them is really something that makes me happy to go to work every day. So thanks everybody, appreciate it. And John, keep us posted on exciting progress with the Guildhouse. There's already so many incredible visions from Fleet and all the amazing visionary designers at Rensselaer. So we'll keep you posted, and thanks for joining.
Thank you.
Take care, everyone.
Thank you.